In this video, we're going to be looking at algorithms for whole number multiplication and division. In this video, we're going to be talking about multiplication algorithms, division algorithms, and division by a two-digit divisor. Okay. Let's look at some properties of exponents here. The definition of a to the n for whole numbers. If a, the base, and n, which is your exponent, are whole numbers and n is not equal to 0, then a to the power of n is equal to a times a, and so on, all the way to a, and that represents n factors. In other words, the exponent for n tells us how many times a is used as a factor. And also, a to the first power is the same as just a. Okay? So the n, of course, that's your base. The a is your exponent. Your exponent is n. The a is your base. Let's look at this theorem. For any whole number a and natural numbers m and n, a to the m times a to the n is equal to a to the m plus n. In other words, if you're multiplying powers of the same base, you're going to add your exponents. Okay? And then theorem 3-10 is for any whole numbers a and natural numbers m and n, a to the m raised to the n is the same as a to the m times n. In other words, when you're raising a power to a power, you're going to bring over the base and multiply your exponents. And I'll write a couple of examples here. For theorem 3-9, let's say 6 to the 4th times 6 to the 3rd. In other words, you're just going to bring over the 6 and then add 4 plus 3, which is 7. So we end up being 6 to the 7th power. Or, now for theorem 3-10, let's say 3 to the 5th raised to the 4th. Here we're raising a power to a power, so we multiply 5 times 4, bring over the base, multiply these exponents 5 times 4, that'd be 20, so it'd be 3 to the 20th power. Okay, that's just an illustration of how we use the property of exponents. One is the product rule, the other one is the power rule. Okay, so this theorem 3-9, that's the product rule for exponents. 3-10 is just simply the power rule for exponents. 3-11 is just for any whole number a and natural numbers m and n, a to the n times b to the n. That's the same as a times b raised to the nth power. Okay. So here you got a product of two numbers or two whole numbers raised to a power. And then theorem 3-12, if a, m, and n are natural numbers where m is bigger than n, then this one is the quotient rule. A to the m divided by a to the n is equal to a to the m minus n. So when you're dividing powers of the same base, you're going to subtract your exponents. So theorem 3-12 has a special name called the quotient rule. So in other words, let's say 7 to the 4th divided by 7 to the 2nd. I'm dividing powers of the same base, so I bring over the 7 and then subtract 4 minus 2, which is of course 2. So it end up being 7 to the 2nd power. And here's some examples of this. We're going to write each of the following with only one exponent. In part A, you got 2 to the 4th, 2 to the 6th times 8 to the 5th times 16 to the 3rd power. Now here's how they work this problem out. They brought over the 2 to the 8th power. 2 to the 6th. But for the 8, I can write 8 with a power of 2 as 2 to the 3rd. So that'd be 2 to the 3rd raised to the 5th power. 16 can be written as 2 to the 4th. So that's 2 to the 4th, and then that's raised to the 3rd power. These two I can use the power rule because I'm raising a power to a power. So bring over 2 to the 6. 2 to the 3 times 5, that's 15. And then 2 to the 4 times 3, that'd be 12. So I got 2 to the 6 times 2 to the 15 times 2 to the 12th. Okay, I'm raising a power with the same base. I'm taking the product of the power with the same base. So that means I can add the exponents. So bring down the 2 and add 6 plus 15 plus 12. That will give you 2 to the 33rd power as your final answer. Now look at part B. We got 9 to the 4th times 36 to the 5th power. That 9, I can write that as 3 times 3 or 3 to the 2nd. So here this will be 3 to the 2nd times 4 because I got the 4 already here. Times 36 is like 4 times 9, but 4 can be 2 to the 2nd. So here's 2 to the 2nd. That's going to be raised to the 5th. And then the 3 is 3 to the 2nd. 9 is 3 to the 2nd. That 2 is raised to the 5th power. Raising a power to a power here. And also multiplying your exponents. 3 to the 2 times 4 will be 3 to the 8. 2 to the 2nd times 3 will be 2 to the 10th. 3 to the 2nd times 5 will be 3 to the 10th. And then these are like bases here, 3 to the 8th and 3 to the 10th. Add those exponents, you're going to get 3 to the 18th, and then bring down times 2 to the 10th. So that would be your final answer there, 3 to the 18th times 2 to the 10th power. Let's look at the multiplication algorithm here. Let's say we have 13 times 3. Using a concrete model, 13 is this, 1 flat, 1 long, and 3 units. But we're doing this 3 times, so now you got this pattern 3 times. So now 3 of these longs, which represents 10, that's going to be 30. And then you got 3 sets of 3 unit cubes. 3 times 3, that's going to be 9. So 30 plus 9 will give you the 39. And here they show you some of the ways that that you can get 13 times 30. Multiplication by 10 to the power of n, or multiplying by a power of 10. To multiply by 10, you just replace each piece with a base 10 piece that represents the next higher power of 10. Replace each unit with a long, and replace each long with a flat. Because those base 10 blocks do represent powers of 10. So in this case here, 23, if we were multiplying by 10, now 23, if we use the base 10 blocks, 2 longs, 3 units. Each long will be replaced with 2 flats because we're multiplying by 10. And each unit will be replaced with a long. So this represents 230. So 10 times 23 will be 230. And another algorithm is multiplying using expanded notation. So if we wanted to multiply 367 times 4, we bring over the 4, but that 367 we can expand that to 3 times 10 to the 2nd, plus 6 times 10, plus 7. And then the next step is use the distributive property. 4 times 3 times 10 to the 2nd is this. Then 4 times 6 times 10 is this. Then 4 times 7 will be this. And also we can use the associative property. We can group the 4 and the 3 together, multiplied by 10 to the 2nd. Group the 4 times 6 together, multiplied by 10. Bring down the 4 times 7. Now 4 times 3 is 12, times 10 to the 2nd, which is going to be 1200. 4 times 6 is 24. Multiply that by 10, that's 240. 4 times 7 is 28. Now add 1200 plus 240 plus 28, that will give you 1468. And this is also illustrated this way. 4 times 7 is 28. 60, the 6 is in the tens place, so that's 60 times 4, that's going to be 240. The 3 is in the hundreds place, that's 300 times 4, that's 1200. Add 1200, 240, and 28 together, that will give you the product of 1468 as well. Let's look at multiplication with two-digit factors like 23 times 14. In this case, we got the illustration here where if you do 10 times 20, that will give you 200 or 2 flats. And then, in this case, 10 times 3, which is 30, or 3 longs. And then 4 times 3, that would be 12 or 12 unit cubes. And then here, 4 times 20, that would give you 80 or 8 longs. So if we add all this together, you'll get 322. As this 12 represents the 12 unit cubes, the 80 represents the 8 longs, and then you got 3 more longs, and then 2 flats. So add these together, you'll get 322 as the product of 23 and 14. Okay, another way of showing multiplication is through the lattice multiplication method. In this case here, we want to multiply 23 times 14. Here, we're going to have 4 boxes. Now, why is that? Because we're multiplying a two-digit number by a two-digit number. So that means we have 4 boxes. Each box will be split into triangles, put diagonally. And then we're going to multiply each digit on top by each digit on the right. Okay. We fill in the top number and the bottom number. If it's less than 10, we put a 0 in the top. So like 1 times 2, that's going to be 2. So 0 goes here and the 2 goes down here. And then 1 times 3, that's going to give me 3. So here, 0 goes here and the 3 goes here. For 4 times 2, that's 8. 0 goes here and the 8 goes there. 4 times 3 will be 12. The 1 goes here and the 2 here. Then we add along the diagonals here. And we might have to do some regrouping in this case here. Bring down this 2 because there's nothing to add to it. 8 plus 1 plus 3, that's 12. Write the 2, regroup with the 1. Then you got 1 plus 0 plus 2 plus 0, which is 3. And there's nothing to add the 0 to, so that's fine. So we got 322 for the product of 23 and 14 using the lattice multiplication approach. Let's look at some algorithms for division. Here you're using repeated subtraction to develop the standard algorithm. So if we want to do 726 divided by 6, we can subtract 600 or 106s. Because if we keep subtracting 6 time after time and time again, it'll be time consuming. So a quicker way is to subtract 106s or 600. That'll leave us with 126. 10 6s or 60, subtract that, that'll give us 66. Subtract 10 more 6s or 60, that'll give you 6. And 1 more 6 will give you a 6. Now we've done 100, 10, 1, and 6, and 1. 110, 10, and 1. Add those together, you're going to get 121 6s that were subtracted. So 726 divided by 6 will be 121. Or you could do it this way. Again, 106s or 600, 26s or subtract 120, and then 1 6. So 100 plus 20 plus 1, or 121, which will be your quotient. And here's another way we can do this. Pretty much this is the standard out approach here. 6 goes into 7 1 times, which is going to be a 1 here, so that represents 100. 100 times 6 will be 600. Subtract 600 from 726, you'll get 126. Then divide 6 into 126, that's going to go 20 times. 20 times 6 is 120. 120 from 126 will give you 6, and then 6 into 6 will go 1 time. 1 times 6 is 6. 6 from 6 will give you 0. Add 120 and 1 will give you 121. Or the short way of doing it, as most people have been doing it, would be this way. Also, we can use base 10 blocks to develop a standard division algorithm. Here we want to represent 726 with base 10 blocks. Okay, so now we're dividing by 6. Now we want to determine how many sets of 6 flats there are. There's only one set of 6 flats, with 1 flat, 2 longs, and 6 units left over. Okay, so we got that. Now what we're going to do with that 1 flat is to convert that into 10 longs, as you see here. That 1 flat that was left over was converted into 10 longs. So now I got 12 longs and 6 units. Then we want to determine how many sets of 6 longs there are in 12. If we do that, we have 2 sets of 6 longs with 6 units left over. Okay, and then determine how many sets of 6 there are, and there's only 1 set of 6 units with nothing left over. Okay, so that's 121. That's the representation of 726 divided by 6. And then another division algorithm will be short division. So here you want to decide where to start. Like in this case here, 2,880 divided by 5. We divide 5 into 28. That would go 5 times. Okay, now we divide the hundreds and write down the remainder by the tens. We got 3 left over, because 5 times 5, that's 25. 25 from the 28 will give you 3 left over, so we write down the 3 here. And then we divide the tens, write the remainder by the ones. So here, 5 into 38 goes 7 times. Well, 7 times 5, that's 35, but 38 minus 35 will leave me 3 left, give me 3 left over, so that 3 goes here. Now divide 5 into 30, that's going to go 6 times. And 6 times 5 will give me 30, so I won't have anything left over. So 2,880 divided by 5 will be 576 as the quotient. And the 4-step method for division by a 2-digit divisor, you want to estimate first, then multiply, subtract, then compare or check. And here's an example of that. We want to divide 2,618 by 32. You want to estimate the quotient. The quotient is going to be a number between 10 and 100. Then you want to find the number of tens in that quotient. So we want to think of 32 going into 261. Because we know 32 can't go into 2, 32 can't go into 26. But 32 can go into 261 8 times. So it'll be 80 times 32, or 2,560. Subtract the 2560 from the 2618, you'll get 58 left over. And then you're going to find the number of units in that quotient. In other words, how many times 32 can go into 58? In this case, only 1 time. So multiply the 1 times that 32, you'll get 32. Subtract 32 from the 58, you'll get 26. And can 32 go into 26? Obviously not. So here, 80 plus 1 will give you 81. And you will have a remainder of 26. And that's a short way of doing that. 81 remainder of 26. To do the check, you always take the quotient, multiply it by the divisor, and add the remainder. take 32 times 81 first, then add 26 to it, and you'll get 2,618 as the dividend. So that tells you that the correct answer for that problem will be 81 with a remainder of 26. And that would conclude this particular section on the algorithms for whole number multiplication and division.